Okay, so in this task, we're going to be simulating the electronic structure of the krypton atom. So we've got our tablet screen here, our homepage. The first thing we're going to do is launch the WebMO app, which you can see in the bottom at the center of the screen. So we just tap on that white icon with the blue molecule, and that launches WebMO. So WebMO allows us to construct and simulate molecules. In this instance, we're going to use it to simulate an atom, and in particular, we're going to simulate the electronic structure of an atom. Now, we want to simulate the krypton atom, so what we first need to do is select a krypton atom. We've got a set of options at the menu on the top of the screen, and 4 or 5 in from the left, we have one that says P table. So if we just touch on P table, we'll get a periodic table. You see by default it's selected a carbon atom. What we're going to do is instead we're going to select a krypton atom. So there's the krypton atom selected. You can see just above at the bottom of the screen, just above the green build option, you'll see it says build KR. And all we want to do is create a single krypton atom. So we can tap anywhere on the white part of the screen and a single atom will appear, a krypton atom. And then what we want to do is we want to run a simulation of the electronic structure of that krypton atom to find out how the electrons occupy atomic orbitals in this atom. So to do that, we select from the bottom menu, the right-hand option, WebMO. And then we have a new set of options along the top, and we're going to select the second one that says Submit. So when we select Submit, we should get this screen which says Configure Gaussian Job Options. So there's lots of options here that we don't need to worry about. Gaussian is the piece of software that we're going to use to run the simulations. We don't need to worry about what the details of Gaussian are. We just need to select a few options here. So the first thing we need to select is the calculation type. So where it says calculation, we just touch the drop-down menu. We've got a set of options there. We need to scroll through them until we get to the one that says molecular orbitals. So select molecular orbitals. Now we need to select a theory. So what we're performing here are what are called quantum chemical simulations. So we're going to worry about the quantum mechanics of how electrons interact with each other. And actually describing electron-electron interactions quantum mechanically is quite difficult. And so we use a range of approximations. And so what this theory option here does is allow us to select the approximation that we're going to use. So if we just select that, the default is something called Hartree-Fock theory. We're going to use another theory called density functional theory. But the option that we want to select here is this first option, B3-LIP. So it's a way of modeling the interactions between electrons. And then finally, what we need to do is we need to select a basis set. So a basis set describes the ability of electrons to move around in an atom or a molecule. And we can think of having small basis sets and large basis sets. Larger basis sets allow electrons to move around more freely and they give more accurate results. So we're going to select a large basis set here. So if we click on the drop-down menu, we've got a choice of basis sets. We're going to choose the one that says CCPVTZ. And that's everything we need to do here. We've set up the calculation. So all we need to do now is, you see at the bottom of the grey part of this menu, there are 2 arrows, one to the left and one to the right. We're going to select the arrow on the right, which will submit the job. And this takes us to a new screen where it shows a set of jobs running. I've run several jobs in the past, but the top row says running for the current calculation. And it's just finished. It took around 6 seconds. So that means the job was completed. The status says complete. So what we do is we just click on the name of that job. The name is listed in blue. So we just click on name and it loads the job. So we've got the same atom as we had before. But now this is containing information about our simulation. And we can see that information by going and selecting results from the menu at the top. And here we're given quite a lot of information. Most of it you don't need to worry about. One piece of information we will use a little bit later is the total atomic energy. It's this one that I've just highlighted there. It says RB3 lip energy, because this is the energy calculated using this B3 lip model that I mentioned before. And the units here are Hartrees, which is the atomic unit of energy. You're probably more familiar with electron volts. A Hartree is 27.212, I believe, electron volts. So it's quite a large energy unit, but much smaller than, for example, a joule. We'll use our total energies later in this activity to think about ionization energies, but for now it's just worth noting that this is where we would find that information. We also get some other information in here, for example, partial charges, and it tells us the atomic charge of an atom in a molecule, but of course when we only have a single atom in a neutral system, that charge is going to be 0. And we can also view the molecular orbitals. We're not going to do that here, but this gives a list of all of the orbitals the electrons are occupying. You'll have some familiarity with atomic structure in the sense that electrons occupy orbitals. Well, the same can be said for molecules. So in this case, our molecular orbitals would correspond to atomic orbitals. And we will investigate the atomic orbitals of krypton in the next activity.